Okay, this is the review for the functions quiz on lessons 1.6, 1.7, and 1.9. The directions to the first problem asks you to give the domain and range for each relation. So anytime two numbers or a group of numbers is related to another one, that's simply called a relation. But a domain and range is usually a very easy thing. A domain is like a set of numbers. In this case, it's a set of x values. And the only rules for this are that you want them to be listed from least to greatest, and that you don't want to repeat any numbers. So if I'm looking strictly at the row of x's here, I'm going to get -3, -1, 0, 4, and 8. And that's all of them. I'm also going to do the same thing for the range, and the range is simply either the y values or the f of x, either way. In this case, it's also the same kind of thing. List from least to greatest and don't repeat. So I have the -3 and the -2. I have a 4 here. And then the number 5 actually shows up twice. So I won't repeat it, I'll just write it one time. And so the range in this case actually has one less number than the domain, because the range values had a repeating number that you do not write. For part B, it's the same idea. Domain is a list of all of the x coordinates from least to greatest. So I see -2, -2 looks to be the lowest one. Then +1, that actually shows up twice, so I'll only write it once. So I'm kind of taking these out as I go. And then I have 2. 3 shows up twice. And then that 5. The range, this time they actually are y values. So again, lowest one would be -2, then -1. The 1 show up twice, and 5. And actually, I see a -5 out here that I left out, so I'm going to go back in and put that one over here. And so be least to greatest. I'll close that off so that's all. The domain and range is usually a very simple thing. The list of all the x values and a list of all the y values. Okay, number 2 says, how do you know whether or not a relationship is a function? We're talking just in general. What does it mean to be a function? Well, relationships are any two numbers or any numbers that are related together. A function has a very specific rule. It's basically saying that anytime you have one input, that you get exactly one output as an answer. For example, something like x plus 2. If you stick a 1 in for x, you get 3 as an answer. You don't get anything other than that. That's a function relationship. If you're looking for something where you have one input, gives you exactly one output. So with that in mind, then numbers 3 through 5 ask you to determine whether or not the relationship described is a function, and if you answer no, you need to explain or at least cite an example of why it's not a function. So for part A, it says, in a one-game bowling contest, the bowler's name to the bowler's score. Well, if you think about it, right, let's say Jim is a bowler. Well, if that's the case, then Jim bowls one game and he gets one score, so he goes directly to that score, and he only has one possible score. So this is a function, yes. Okay, on the other hand, let's say that Jim, who bowled that score, let's say he bowled a 237, just for fun. Good for him. So if he bowls a 237, the other one says the bowler's score to the bowler's name. So now we're going to take 237 and say, does that give us directly to Jim? Well, maybe, but not necessarily. Suppose somebody else also bowled a 237. So you could say, well, what if it also goes to Joe, who also did it? It's possible that both of them could have bowled a 237. So the way you would say this is to say, no, it's not a function, and that you could say that that score leads you to multiple names. Okay, so let's try to apply that same logic to part C. Snuffleupagus, the very lovable woolly mammoth character on Sesame Street. Does T lead you automatically to a Sesame Street character? Again, unless you name the small child Snuffleupagus or something, most likely you're going to say yes to that one, right? Because he is only a Sesame Street character. Okay, on the other hand, if you say Sesame Street character to Snuffleupagus, well, if you think about it, the Sesame Street character automatically leads you to just Snuffleupagus. And here I think you could easily say no. You say Sesame Street character could lead you to Cookie Monster. Or any other Sesame Street character. Or to Elmo. So see, because you can get more than one output out of Sesame Street character, it means that this is not a function. So here we're looking for the same kind of thing. Do we have a function relationship? This time it's numbers. What you're saying is, does x give you exactly one y value? Well, if you look at it right, 1 gives you just 4, 2 just 3, 3 just 2. Notice how the x's never repeat. If that's the case, then that means every x gives you only one y. This is a yes. But see, in part B, we have this one and this one, where what we're saying is 3 could give you 3, or it could give you 2. Since you have that, you would say no, that's not a function. And finally, checking graphs to see if they are functions. A pretty easy thing to do, I think. Basically, you're going to use the vertical line test. Anywhere you can draw a vertical line on one of these things, where it touches the graph more than once, if you can do that, you prove that it's not a function. So you see over here, no matter where I draw this vertical line, it always touches the graph only one time. So A is a function. So again, you're looking for whether or not it touches more than once. Since it doesn't, this is a function. Let's see, if we do it to this picture, anywhere, you can see where it touches the graph multiple times. This is definitely a no. Believe it or not, there is no Ninja Turtle function. So if we go to the last one, this is called a sine or cosine wave. If you draw a vertical line only one time, no matter where you draw it. So again, this one is a function. Okay, number 6 takes you to the next step, which is evaluating a function. Just saying, okay, it is a function. Now, tell me what the function is when x is 0. Tell me what the function is when x is negative 2. And tell me what it is when x is 1/2. So all we're doing is sticking this number in for x and getting an answer. The first one, f of 0 for this, would be negative 3 times 0 minus 2. This is 0, so you get 0 minus 2. F of 0 is just equal to negative 2. So you're just substituting in these values in for x. So we would say f of negative 2. That one has to be negative 3 times negative 2 is positive 6. Minus 2 would give you 4. And finally, f of 1/2. If you don't like dealing with the fractions, you could always change it to 0.5. We have negative 3 times 0.5, that's negative 1.5. Minus 2 more gives us negative 3.5. So here again, I'm just going to stick in the 0 for every x in the problem. So it doesn't matter that there are 2 of them, it's still a 0 for both. That's going to be 0, and so is this, so f of 0 is still 0. Okay, let's do f of negative 2. Maybe if you're using a calculator, this would be a way you would want to write it or type it into the calculator so that you actually get the correct answer to it. So negative 2 squared is 4, times 4 is 16. So this part is 16. And then these two negatives make that a positive. So it's actually 16 plus 4. This is 20. finally f of 1/2. Okay, if you put a 1/2 in for x here, you're going to see that this actually works out pretty easily. Well, 1/2 squared is 1 squared over 2 squared. In other words, 1/4 times 4. 1/4 times 4 is going to give you 1. Minus 2 times 1/2 is still 1. So you have 1 minus 1. This turns out to equal 0. And for the last one, I'm just going to shortcut these a little bit because I think you guys can do this one. This one is 3. That's going to be positive 2.5 or 2.5. This one is going to be 1/8 plus 3, so 3 and 1/8, or if you work out a decimal for it, it'll be the equivalent of that. Okay, for number 7, it's asking you to graph the following points and state which kind of function relationship is illustrated. Okay, just to save some time here, I'm not going to graph all of these points. I'm going to trust that you guys can graph the points. But if you did graph it, it should look something like this. And if that's the case, you should recognize this shape as a parabola, and then you would call this one a quadratic function. This one over here, if you scaled your graph right, you might notice that you only need the positive side of it. And if you did it correctly, it would look like that. This one is a square root function. So when you go to do these problems, the only choice you really have is to say that the quadratic is a parabola. You just kind of have to memorize that. There's no other way of going about it right now. Same thing for square root, same thing for cubic with a hyperbola, and linear for a straight line. All right, last steps. These ask you to look at an equation and identify the parent function. What you're looking for is a variable raised to an exponent. In this case, you have x to the third. That makes it cubic. Here we have the biggest variable exponent right here, x squared, that's quadratic. So all the other stuff in the equation, all of this really doesn't matter. What matters is the variable with the highest exponent. Here, it's just a plain x. So 1/2 means nothing, neither does a minus 3. It's just a plain x with no exponent, or an understood 1 there. This is linear. Actually, same thing here. This one is also linear. Over here, we got a square root on this one. Obviously, that's a square root function. And here, even if you look at all this other stuff in here, ultimately the only thing that matters is this one right here, x to the third, the highest exponent is cubic. Okay, I'm going to give you guys an opportunity for a bonus tomorrow. Everybody's going to get this chance, but you're going to get a graph of some sort that is going to ask you to take it's going to ask you basically to figure out a function from its graph. So if I were to give you a graph like this, let me make an x and y axis. Here's your x and y axis. And let's just say that I do a graph on here that looks like this. It doesn't really matter, but this is just an example. If I ask you then, what is the graph at f of 2 What it means is, we should go over to where the function is 2, right here. Here's x is 2. Where is the graph? Right there. So with that point right there, that says if x is 2, then y is 2. So this would be 2 like that. You can do it for just about anything. If f is f of negative 3. Well, where's x is negative 3? Right here. Where's the graph? Positive 3. One more. F of 7. Go over to 7. 1, 2, 3, 4, 5, 6, 7. Where's the graph? Up here at positive 4. This is 4. So I didn't put that on the review paper. I kind of forgot about it, and I shouldn't have. But in this case, then it's very possible that this could be a bonus question.